Hello all. So in the last session we were talking about machine translation systems. How do we evaluate machine translation system? Today in this session I would like to discuss about how do we build our own chatbot. Okay. So basically all of us have very clear idea about what chatbot is. So a chatbot is basically a computer program that copies human communications in its natural format, including token or including text as token or spoken language using different AI procedures, and one such procedure is natural language processing. So in many cases when we build a chatbot, we include image, videos and audio analysis as well. So for now, let us consider chatbot as basically the implementation of conversational interface. Okay, so when we talk about conversational interface, it is all about intelligently machine handling the conversations with human. Okay, so chatbots are of different types: textual type, voice based, image based, etc. So when I talk about working of chatbot, there are basically two different ways in which a chatbot works. One is called rule based and the second one is called smart machine based. So when I talk about rule based, the rule based chatbots gives us the predefined responses from a database. That is, we take a database, for example a Wikipedia page, and ask a few questions about it. That is what we're going to implement it today. And apart from that, we also have smart machine based, which uses AI and cognitive computing, which will adapt to the operation based on the customer interactions and gives us the possible technical answers. Okay, so we have different categories of chatbots that we can build using NLP. So the two important or basic methods are scripted and artificial intelligent chatbots. Okay, so if we want to discuss about scripted, this basically these works on predetermined text. As I told you, take a Wikipedia page, store it in the library and ask questions from that, and the chatbot will give you the answers based on that particular thing. Okay, so this makes the kind of chatbot difficult to integrate with NLP aided speech to text conversation modules and so on. So for various reasons, for limited applications based on our usage, we limit it to scripted. If you want to go for more advanced, we go for artificially intelligent chatbots. These chatbots, as the name suggests, they work how like humans work, give responses like how humans do, understanding the question. Okay, so NLP actually plays a major part in building chatbots because the questions that are asked is human voice or text or speech. So we have to understand the dialects, the tones of the human conversation, and respond accordingly. So for that reason, we use artificially intelligent chatbots. So NLP basically combined with AI creates wonderful chatbots that are being used by almost, you know, every corporate or every website will have chatbot, its own chatbot, wherein the humans interact with the computer. Okay, so the AI chatbots have been developed to assist human users on different platforms through their automated chat support or virtual assistants, helping with the for various purposes. So let us start working on building the chatbot. The first step, as all of us know, is importing required libraries. So here I've imported my libraries. I've imported NLTK, NumPy, and the most important library that I'm using is Beautiful Soup. Okay, we'll explain you about it in the coming days things. Okay, now after I import the libraries, we'll create the corpus. Okay, so Beautiful Soup is one of the most important libraries in Python, which is used for NLP, which is used for navigating, searching and pulling data from HTML or XML web pages. Okay, if you want to pull the data from the web pages or Wikipedia data, we use this Beautiful Soup library. Okay, so for now, for this particular chatbot, I've taken a Wikipedia article on tennis. Okay, just simple tennis page, and from that tennis page I want to create the corpus. So we will try to retrieve the Wikipedia article on tennis and extract all the paragraphs from the Wikipedia page, and then we process the text, that is converted into lowercase for easier pre-processing, and then we will be using Beautiful Soup library to parse the data from the Wikipedia. Okay, that is, it navigates, searches and pull the data from the XML page. And then the most common method for finding anything on the web page, or find all. Okay. Now once I import the libraries, what I do is I go for URL library request, URL open, that is Wikipedia, Wiki tennis. Okay. Now I'll try to read the data, and using beautiful soap I'll extract the raw data, and then I'll extract paragraphs and convert that into lowercase sentences. And using this find all method, as you can see, using this find all method, we are using this to find out all the tags with a specific tag name or ID. Okay, you can do that. You can incorporate any number of find all tags and then use it in your data set for the corpus that you have taken. Okay, now after I do that, I'll go for text pre-processing. I've imported the library, I've imported the data set from Wikipedia page. Now I'll try to pre-process the data. Now we'll pre-process our text to remove all the special characters. You can see we can do stemming, lemmatization, tokenizations, and parsing, all these different things. For now, for this particular thing, I have removed all the special characters and empty spaces from the text by using RE, regular expressions. As you can see, I've imported regular expressions here. Using that RE, I have removed all the special characters. And once I am done with that, we will divide the text into sentences and words. Okay. For that, I am downloading the data set. From NLTK, I am downloading Puncti. Okay. Now I am performing tokenization, that is word tokenization on the article that I have taken. So once we are done with this, we will use helper function. Okay, please make a note of this. We use helper function, and the main usage of this helper function is it will remove the punctuation from the user input and will also lemmatize the text. Two different operations done by only one function, which is called as helper function. Okay, what is the need for lemmatization? Lemmatization will reduce the word in its root form. So different words which are available in different root forms will be considered as one word. So it is very important steps in text pre-processing, as I have discussed about it earlier. So we'll do lemmatization, and once I am done with word lemmatizer, we can use different. You can go for a define function and then perform lemmatization on all every tokens using for tokens in tokens, or you can directly take the document and perform word tokenization onto that. Okay, so in the first, as you can see, in the first we instantiate wordnet lemmatizer. First I go for wordnet lemmatizer from the NLTK library, and then I'll define a function called as perform lemmatization. Okay, which takes this first function. I'm talking about the first function, which takes list of words as input and lemmatize the corresponding lemmatized list of words. Okay, and then after I do the lemmatization, I'll go for punctuation removal, which removes the punctuation from the parsed text. Okay, after that we will go for get pre-processed text. Okay, so once we get the processed text, I will take that particular method which will take sentence as input, tokenizes it, lemmatizes it, and then removes all the punctuation marks. Okay, so I am doing this, and then I want to respond to my greetings, right? If I want to say hi, hello, basically we start with this, right? When we talk about conversation or chatbots, we directly don't go to the information. We want to give the basic information that will not be available in the Wikipedia page that I've taken. So firstly, I'll start with responding to the greetings. I'll create a simple corpus which will respond to the greetings, which usually a chatbot will handle depending on different types of user inputs in different manner. So for instance, we have created a greetings underscore inputs, in which I give different types of greetings that we usually use. Hey, good morning, good evening, morning, and all that. And then for each and every word, how do I respond? Greeting responses also I've created. Two lists. I've basically created two lists. Okay, and then when a user enters a greeting, we'll try to search in it for the greetings input. In the greetings font, we randomly choose a response from this particular list. Okay, I've defined a function for that. Okay, now here I've created a function called generate greeting response, which is basically responsible for validating the greeting messages before we actually start with the information or responding to the user queries. So after I create, we'll start responding to the user queries. So as we said earlier, the response will be generated based on the cosine similarity of the vectorized form of the input sent and the sentence in the corpus. So let's import tfid f vectorizer and the cosine similarity functions. So for which I have used sklearn library. So I'll first go for importing TF-IDF. Okay, TF-IDF vectorizer from sklearn feature extraction, and for which if I want to calculate the cosine similarity, I'll go for sklearn.matrix.pairwise, with which I can calculate the cosine similarity. So once you have imported this, we'll try to define a function for generating the response. So when I develop this particular thing, first the input will be the user input. As you can see, the generate user response methods will accept the parameter which is user input. Okay, now after that we define an empty string. As you can see, tennis robo underscore response is an empty string that I have created. Now we then append the user input the list of already existing sentences after that in the following lines. Okay, so we generate each and every line. Okay, so based on the corpus data that we have taken. Okay, if suppose there is anything that is not matched, okay, we try to match the cosine similarity and generate the output responses accordingly. If there is anything that is not matched, so we generate a common message: I'm sorry, I could not understand you. If there is anything the user is asking apart from the database that is available, as you can see in your real time when you go for Swiggy, if you talk about delivery, if you talk about food, if you talk about the rating or review or complaints, it'll answer you. But if you talk something about which is not related to Swiggy delivery app, then it will commonly generate some random answer. So here I have taken, I am sorry, I cannot understand you. You can put your own answer there. Otherwise, if the matched vector is 0, it will generate this answer. If the matched vector is according to the data corpus that you have taken, it will respond and give you the particular response. Okay, now I'll import NLTK. I'll try to download all the packages from NLTK, and I'll try to start building my word vectorizer. So as I've already taken, we have taken TF-IDF vectorizer. So we get the pre-processed text, we start the words, I mean the language that I'm choosing is English, and we'll start building a chatbot. Okay, so we first initialize the TF-IDF vector and then convert all the sentences in the corpus along with the input sentence into the corresponding vectorized form. Okay, after we do that, we use the cosine similarity function again to find the cosine similarity between the last item in all the word list, which is the actual word that the user input have created, and the word vectors for all the sentences in the corpus. So we just compare that. Okay, so after we are done with that, chatting with the chatbot as a final step, we need to create a function that allows us to chat with the chatbot that we have designed. For doing this, what we will do is we again use the helper function that will actually keep executing with the user types. Okay, so I have created a function called vectorized function there, and I'm using that to generate the answers based on the continuous dialog that I am doing. Okay, as you can see, once I execute this, it will give you hello. I have basically created the welcome page as hello, I am your friend tennis robo, you can ask me any question regarding tennis. Okay, so this is a welcome page, welcome note that I've taken that. So I have responded to as hi. Okay, the tennis robo nods. Okay, so can you explain me more about tennis is the question that I've asked. So it says the US National Men's Championship. So whatever the data that is there in the corpus, this is rule based. Okay, that is, I am not building an AI chatbot here. I am building the chatbot from the Wikipedia corpus. So next I have typed what is Wimbledon. Mistakenly or wantedly I have taken Wimbledon spelling as wrong. So it has given the answer, I am sorry, I could not understand you because Wimbledon spelling is wrong and the word is not exactly available in the corpus. Now next I say sorry, Wimbledon 2024. So when I give this, it searches for the word Wimbledon and gives you the answer from the Wikipedia page that I've taken. Okay, now let me type one more answer here. Question here, can you explain about the game? Okay, when I type this particular question, it gives you the US National Men's Championship now is open. Okay, so this is not AI based chatbot, as I already told you. This is based just on the Wikipedia text I am taking. Okay, so you can take any Wikipedia page and try to generate random questions and build your chatbot this way. Okay, so basically human language is chaotic despite its structure. So we have different challenges that we actually face when we build a chatbot. Okay, so we have to deal with synonyms, antonyms, slang, misspellings, abbreviations. As you can see, misspelling Wimbledon is not available as WEMBEL. Okay, so misspellings, and then punctuation rules, different accents. So all this plays a major role when you build a chatbot. Okay, so this is all about how do we build a chatbot using your tool-based chatbot using NLP. Okay, so this is all about that. Thank you so much.